Molarity. Let's talk about how to calculate molarity in this video. First of all, you need to know the equation. Molarity is represented with a capital M, and the equation for molarity is moles divided by liters. So I can throw you a couple of curveballs with these types of equations. For example, instead of giving you moles, I can give you grams and have you first convert from grams to moles. And then the other kind of curveball I can throw at you is instead of giving you liters, I can give you milliliters in the problem, and that would also make you convert from milliliters to liters. So let's dive on in here. The first example is very straightforward. It says as a solution has 0.5 moles of sodium chloride, and the volume is 0.2 liters. Please calculate the molarity. Well, this one's very straightforward. I am given moles, I am given liters. I can simply just plug and chug here. 0.5 moles is my numerator, 0.2 liters in my denominator. Punch in your calculator 0.5 divided by 0.2. You should end up with 2.5 for your molarity. Notice how I'm also using that capital M kind of as my unit there. That just means molarity. So 2.5 capital M should be your final answer for this problem. This one's very straightforward. Again, it gave you moles, it gave you liters. Both of those can simply just plug right into my equation. Now let's look at one that's a little bit more tricky. Let's take a look at this example. So this solution has 0.75 moles of sodium chloride and a volume, of 300 milliliters. Okay, so going back to my molarity equation, can I simply grab milliliters and throw it in here where you have liters? No. No, no, no. You must convert. So off to the side, I'm going to do a quick little calculation. If I have 300 milliliters, I am simply going to convert that to liters, and 1 liter is equal to 1,000 milliliters. So essentially all you have to do is divide by 1,000. All that does is move your decimal point 3 spaces to the left, and you should end up with 0.3 liters. Now that I've done this quick little conversion, I can simply take this number and plug it in for my denominator. So let's go ahead and do that. Let me write out my equation here. Molarity is equal to moles per liter. The moles was given in the problem as 0.75. And we just calculated liters. Please don't make my favorite mistake and accidentally put 300 milliliters here. If you did that, please cross it out. You cannot use milliliters. This equation specifically has you using liters. So my conversion was 0.3, let me use green here, 0.3 liters. Once you punch that in your calculator, it should be 0.75 divided by 0.3. You should end up with 2.5 for your molarity. Again, notice how I'm using a capital M there for my unit for molarity. Okay, one last curveball I want to show you before I turn you loose to work on this stuff. I can also give you grams. So here's my molarity equation. We know it's moles divided by liter. As I read this problem, now we're given grams here. And I also have liters. Liters I know can simply just plug in here, no big deal. But my grams, I cannot simply just grab grams and toss it in the equation where it clearly says moles. Nope, I have to do a conversion first. So let me set this up here. I'm starting with 5 grams of calcium chloride, and I'm going to convert to moles. We know 1 mole will be up top, and the molar mass will be in the denominator. Where do I go to find the mass of 1 mole of calcium chloride? That is your periodic table. So I'm going to do a little side calculation here and calculate the molar mass. I'm going to add up 1 calcium. When you look on your periodic table, it should be 40. And I'm actually going to add up 2 chlorine. So whatever the molar mass of chlorine is, once you check that out, it should be 35. I'm going to multiply it by 2 because in my equation, I have a subscript of 2 there, so that should be 70. Once you add them up, 40 plus 70, you should get 110 grams for your molar mass. What can I do with this number? I can plug it in here for my mass to mole conversion. That's exactly what I'm going to do. 110 grams. That number came off the periodic table. So once you solve this, punch in your calculator 5 times 1 divided by 110, and then depending on how you round here, you should get 0.045 moles of calcium chloride. Perfect. Now that I've done this little side calculation, I can now plug it in to my molarity equation in the numerator for my mole value. So that's exactly what I'm going to do. Molarity equals the moles I just calculated, so I can plug that in for my numerator, 0.045 moles, depending on how you round. And then this problem actually gave me liters. That was just right there in the problem, so I can simply just toss in 2.5 liters, go ahead and divide, and you should get your molarity of about 0.018, and my unit will be capital M, again representing molarity. So there's my final answer. How did I get that? 0.045 divided by 2.5. This is about as tricky as they can be. Again, this problem gave me grams. Another thing I can do, instead of giving you grams and liters, I could give you grams and milliliters and actually make you do 2 small conversions before you can even get to your molarity equation. They're not too bad. You just have to really watch those units and make sure you convert where you have to. This has been a Rodriguez original production. I hope you learned about molarity. Enjoy, go back, rewatch it, study, practice more examples. Good luck.